Let's talk about impulse. Impulse is derived from Newton's second law. F net is equals to ma, and in place of a, you substitute Vf minus Vi divided by the change in time. Okay, so from Newton's second law, we have the resultant force or the net force being equals to the change in momentum divided by the change in time, of which we know that the change in momentum is the mass multiplied by the final velocity minus the mass multiplied by the initial velocity, everything divided by the change in time. Obviously, we can cross multiply. If we cross multiply, we get the resultant force multiplied by the change in time being equals to the change in momentum. So the resultant force multiplied by the change in time is what we call the impulse of a force, right? Of which the impulse of a force is equals to the object's change in momentum, right? Of which the force is applied on. We need to remember this. The impulse of a force is equals to the change in momentum of an object. When a force is applied to an object for a short space of time, it will bring about a change in the momentum of the object. Let's dive deep into impulse by starting with the definition. So the impulse is the product of the force applied and the contact time. That is the impulse. The impulse is the product of the force applied and the contact time. So since force is a vector quantity, impulse is also a vector quantity, and its direction is the same as the direction of the force, right? You will see this in detail when we start solving some problems. Like we've said before, impulse is equals to the change in momentum. Impulse is very important when it comes to safety of vehicles. Let's take a look at that. So impulse and safety considerations. To avoid more serious injuries, if an object can be stopped over a long period of time, a smaller force will be required and thus less damage caused. Because we're saying that F net is equals to the change in momentum divided by the change in time. So if we increase the contact time, F net is going to decrease, right? They're inversely proportional to each other. Okay, so this occurs in the cases of airbags, seat belts, and arrestor belts for trucks and planes. We have a ball moving at a velocity of 30 meters per second. It has a mass of 0.5 kilograms. After it gets hit, it moves to the opposite direction with a velocity of 40 meters per second. The first question is saying, let's find the impulse applied by the bat. And then the second question, determine the force applied by the bat to the ball if they're in contact for 0.1 seconds. Take original direction as positive. So let me show you how we can answer the first question. We know fully well that the impulse is equals to the final momentum minus the initial momentum, which is just mv final minus mv initial. We know that the mass of the object is 0.5 kgs. There we go. And the final velocity is 40 meters per second in the opposite direction, right? So that is going to have a minus sign. So that is why we have 0.5 multiplied by minus 40. And then the mass of the object still 0.5, and its initial velocity is 30 meters per second in the original direction, of which we are taking as positive. If you put that in your calculator, you should get minus 35 kgs meters per second. This is to the opposite direction. So now that we have the impulse, it should be quite easy to calculate the resultant force, because we know that the resultant force is the impulse divided by the change in time. So let's go ahead and see how that will look like. As you can clearly see, the impulse divided by the change in time. So we have minus 35 divided by 0.1, which is minus 350 newtons.